it's Ladyada.
Hey everybody, and welcome to my desk. All sorts of stuff going on this week. Lots of hardware and tronics. So let's kick it. First off, let's go to that multi-view. Well, actually, first, is there any updates or news people need to know about?
No, let's just jump right in. We got a lot of stuff. Do you want to do the overhead and the computer?
Yeah, let's do that thing we were showing off that thing. And I was like, that's
well,
cool thing. Okay, so this is cool. So we are playing around. We got our particle tachyons and we loaded them up. Hold on, there you go. So this is a single board computer from Particle. They made like the Spark core, and then they made like feather-like mesh boards, and then now they're doing like full Wi-Fi multicellular dev boards that have a lot of cool stuff built in that are like compatible with Raspberry Pi accessories. What's going on? And since it is a single board computer that is, has a Raspberry Pi pinout compatible, I was like, well, let's get it working with some of our cool sensors. So for example, this is a BME5xx. This is like a barometric pressure, temperature, gas sensor, whatever. And you can see on the output here, this is from the terminal. So I've SSH'd into the particle tachyon, and I'm displaying the BME5xx test from our CircuitPython library collection. So, one of the decisions I made like 7 years ago when we did CircuitPython was like, let's make sure that we can run all of the libraries that are CircuitPython compatible, API compatible on single board computers like the Raspberry Pi, the BeagleBone, etc. And so thankfully, a developer at Particle actually did fork Blinka, which is our compatibility layer, and added the support for the Particle Tachyon, which it wasn't even that bad. It was like, we tried to make it pretty easy. Maybe it's not the most efficient, but it does work quite well to add, hundreds of boards. And so what's neat is there is actually a STEMIQT port over here, but it uses a different I2C port than like the default, and I just wanted to make it easy. So I plugged in, this is my Pi Stemma board. So it's a little board that plugs in, you can see, and it gives me a Stemma port, and it uses like the main I2C connectivity. So that's really good. So I2C definitely works, and what we're gonna do is mainline. So you want to go to just computer? Is it possible to go to just computer?
We could go to just computer. We have the technology to bend space and time.
Wow, love that. So this is so they did this as part of the tutorial for the Cricket hat because we offered it as one of the stretch goal bonus things. So they're using, like I said, maybe this branch. But one of the things we're gonna do next week is I've asked Melissa, who kind of maintains the Blinka and platform detect code, to add it into mainline, so you'll be able to just do pip install. You won't have to do the git clone stuff. And have it all work. And so the next thing we're going to do is, I think we mentioned this last week, is we wanted to get e-ink working with this. And so development, dev boards, was it dev boards? No, it was under Raspberry Pi bonnets. So I'm going to get the PCBs in later on this week for the e-ink bonnet, get those put together. And since I2C works, I'm almost positive SPI will just work. Usually that's actually not too hard to do. Is I'll be able to get some of the really big, nice e-ink displays that we've been demoing. Hold on, I'm going to get I have a little bin here with some e-ink displays. So we got some really nice, big, e-paper displays. This is a 7.5-inch display. So get that working with the particle tachyon, then we can have it do some cool cellular connectivity, e-paper display projects. I don't know, cool weird stuff. So it's going to come together. So I'm kind of glad that wasn't too bad to get I2C working, and so I think SPI will just they say it works, so I'm pretty sure it will. So I'll get that bonnet working and verify it, because we have Blinka support for SPI e-ink displays as well. Okay, so that's what we're doing with the Tachyon. So I don't know, people who are using this, maybe y'all can test when we merge in support for Blinka. Okay, so next up, so let's move this out of the way gently. Put it on another part of my desk. So the other thing, one thing that was kind of neat, it's because it's been a really long time since I used the particle console is, like they have, like what's cool is you configure it over USB using their like command line tool, and you set up like the Wi-Fi credentials and your key and everything and your account. And then when you log into your console, it just appears, and you can even like terminal in, which I just think is like so adorable. So you can open a shell, and it's actually kind of nice because when you first plug in single board computers like a Raspberry Pi, you're like, what's the IP address? There's no way to know. And it's like we've talked with like other like high level engineers and been like, this is a really hard problem to solve. Because there's no like way, there's no indicator for what the IP address is. And of course it's different every time. And sometimes you can use Raspberry Pi.local, but not if you're in a classroom where everybody else is using Raspberry Pi.local. And then you can like have them know to update it when they burn the SD card, but often they forget. It's just kind of like blah. So it's kind of neat. Like when I need to know the IP address, I actually use the terminal, and then I do like IP config, and then I take the IP address and I SSH locally, so I don't have to go through the web app. Okay, so let me close this and I'll cancel this. Great. So the other thing I did, oh wait, this is for, that's going to be for later. The thing I did is a bunch of libraries. So one is the, go to the overhead again. The BMP580. So we had a couple of people like request getting BMP580, 581, and 585 breakouts, and they are the same physical. The footprint is the same size as the BMP 390, so it's actually was like not a big deal. It's like the next generation, so I was like, okay, no problem. Swapped out, put a 580 on there, and then wrote a library for it. So back at the computer for a second. Let me just make sure we're doing good. So what's nice is that I was able to use, they do have an official library that Bosch wrote. And so I just had to write wrapper code. And so I used Claude with it. And I like now, I don't know, it says like Adafruit developer, but because I'm using WSL. But working with Claude to get all of the, instead of C, having it C++ified, and also making it easy to just like get temperature, check the busy data ready bit, configure the interrupted stuff. But all good so far. This works. So I got this published and released and clanged and everything. So some of the library. So you'll see the BMP 580, 581, and 585. Again, they all use that same library. It's like whenever there's, the library is actually the hardest part. So once that works, I kind of am like, cool, I'll just make any hardware that works with that. Another thing I got done was go back to the overhead again. The BQ25628E. So this is a LiPoly, a single cell LiPoly charger that has I2C configuration and reporting, which I like. And you can, this has iSet, so you can change the charging current, like, dynamically. With a mechanical switch, not just I2C. And you can give it like DC voltage up to 18 volts. So you can give it USB-C. I have a little diode selector. And it has like indicators and lots of LEDs and stuff. And it's a buck converter. So it actually can do 2 amps without overheating. That's the problem with a lot of LiPo chargers is you have 5 volts and you could get 2 amps out of that 5 volt power supply, but the chip itself will overheat. It can't handle like that much voltage drop from like the 5 volts or whatever down to 3.7 volts. And the dissipation is hard for a little chip. So having a little buck converter means that there's no heat dissipation issues. And so you can even have it from 18 volts and it's not linear. So it's like you can have 2 amps from a wide range of voltages, low to high, which is great. I was talking to like a Burning Man, like somebody who works at the Burning Man organization, and they were like talking about engineering and projects. And they were like, how does having gone to Burning Man affect, your, the products and design that you do? And I'm like, this is actually something I would have really loved to have at Burning Man, because I had a lot of projects that were powered off with LiPo batteries. And you don't always have a USB port. Like sometimes you're just like, oh, I have like a DC power, and like the DC power is like flaky and weird. And I was like, man, I would have really loved to have something where I could, like, based on the battery, I could easily flick and switch what the current rating I wanted to, whether it's a 0.5 amp, because it's a little battery, up to 2 amps for a big battery, and it works with any voltage, and it gives me indication and like da-da-da. This would have been great. So
let me break it down for everybody. So when people say, oh, this is something I like because I use it and I bring it with me, that's one thing. This is more saying, if I was ever forced against my will to go back to Burning Man, I have to bring this with me. I'm going to make this now just in case, because I'm not going to have time if I'm kidnapped and then force me to go to Burning Man to do LED projects. I need this already done in the store so I can just grab it.
Yeah. But the thing is that when you're like really stuck in the middle of the desert,
but that's
that's when you're like, what do I really need?
Yeah, it's like, what would you like to bring with you on a desert island? This.
Yeah.
This,
yeah,
right?
Because we were talking about like what USB cables and what chargers and what dead boards. I have a new
list of things now too, especially with the toddler. I'm just like, okay, I could do it.
I designed little LiPo charger boards, but like they were all USB, and I didn't have them. They were all limited, and I couldn't fast charge. And I would have we had power packs, but it's like I could get voltage or solar, but it was again. You couldn't use 9 volts, and then you'd plug in 9 volts by accident, it would blow up. It was just like
I look at like a video game. When something happens, you always have a chance to do it over, unless you're dead. Then you're dead. You don't care.
Yeah.
So I feel like that was like, okay, I learned so much when I went once, and we're going to go in. It's like, okay, if I ever was forced, though, it's like, okay, aliens landed. They have neopixels. Quick. You guys. That's probably what's going to happen.
Yeah.
Okay.
And the I2T I really so one thing I like about this board is quite big because I kind of break out everything and I have a mechanical switch and stuff. But actually the chip and the inductor are kind of all you need. Everything else is sort of like bonus, maybe the one ISET resistor. A lot of the stuff is actually not required. And then it has I2C, and so there might be some situations where it's like, look, what I like is that if I have a board that I want to have monitoring, because what this does is not only give you you can configure it and set the current and trickle charge and turn it on and turn it off and blah, blah, but also tell you what are the voltages on all the inputs and outputs and how much current is being drawn around, because it has a separate battery and load. So it can detect like, is it charging or discharging and what's the rate? And then the voltage, you can actually like do some basically battery monitoring. So I kind of like that. I mean, like, there, I go to the library for like 15 trillion settings, but really the reporting is what's cool. And I wanted to finish this because it's like I'm still working on the driver for this beast, the BQ25798, which is the solar, MQTT charger that can handle multiple cells, multiple charge rates. It can go up to 5 amps. It does buck and boost, and it can do max power point tracking. And I have terminal blocks. I kind of wanted to make like the ultimate LiPo charger. These can also, by the way, do other, like they could do lithium ferric phosphate, LiFePO4. But by default, the voltage is kind of high. So I think you would have to, it's like kind of gnarly because you'd have to put it into disable mode and then not let it charge the battery and then quickly change the voltage so it doesn't float high, even though you have protection on the cells. I wish they had a little, they have iSet, but I wish they had a VSet. One thing I liked about...
Whose company? Who's this?
This is TI.
Oh.
They do on some of their chips, but not on this one. I think on the next gen, they probably will. If you
remember, let's try to, they watch the show. But this is a deep cut. Maybe you remember, you want me to try to remember?
Well, they owe me also a temperature monitoring thing. So
right.
I gotta bug them. Anyway, so this is going to happen too. But I did finish the driver for the BQ25628E. It took a while, but I basically just had like cloud code, I just went through the data sheet. I didn't do every single thing, but I did like the vast majority. And thankfully, the TI data sheets are very well written and they're like easily to parse.
Easier.
So I got that in, and I think this is still a really good. I mean, I think both these are useful, but this is kind of a nice. I like especially being able to select like up to 2 amps. I know a lot of people have these like big, these chunky batteries, and they're like, I want to charge this at 2 amps, but I don't want to have to, I want to have a variety of different charging inputs. Okay, so that's that, and I think that is all I've got. So it's mostly driver work this week. It's not just like driver work in the middle of doing other stuff. Let's go to the Great Search.
That's right.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit every single week. Ladyada brings the power of engineering and her smarts to bring you, yes, you, something that it would be great to search for, and it would be great if you could find it, and it's going to be great.
Okay.
Do it.
So I saw this come by. Yeah, sometimes I'm like, oh, I didn't actually like spec any parts this week. But then I go and look at what like DigiKey's talking about to see if there's any, like great search content there. And they did this like little hack of like, okay, you can, if you have a TO220 and you want to cool it down. And actually reminded me, so one thing that is definitely true that you bump into quite quickly is, you have something like your your LM7805 in a TO220 package. And, the data sheet and the documentation sort of implies like, oh, you can get 1.5 amps out of this at 5 volts up to like, I don't know, 9, 12, 15 volts input. But because it's linear, that is not actually true. Because if you actually like do the math, like let's say do the math. You have a 9 volt input and you want 5 volt output. So if there's a 4 volt drop and you want to multiply that by 1.5 amps, that's 6 watts. And you cannot on its own dissipate 6 watts out of this. In fact, a TO220 unheat sunken can basically give you about like 1 watt, maybe half a watt. So you could do, like half an amp maybe, or a quarter amp. Maybe you could do little spikes of a half an amp, but you will quickly overheat the die inside. But what's nice is that there is this big tab, this metal heat sink tab that you can attach a heat sink to. And so on that little video, they showed like, oh, take a little like bulldog binder clip and you clip it on. And it's like that will give you like a little bit of heat sinking capability. And you could probably get like a couple milliamps more. But you can also just go DigiKey and get like a proper heat sink. So let's go You could. So
Why would you want to do that?
Because it's the Great Search.
Yeah.
So if we search for...
You could do it wrong the first time and then be like, fine, I'll Great Search.
Well, this is a common thing because people are like, well, they wire it up and they're like, well, the data sheet says I can get an amp and a half, but when I actually use it to power my solenoid, my system shuts down. Or
Spherical cow.
Or spherical cow.
Spherical cow. I was talking to someone who works at Amazon.
Yeah.
And I think I'm going to compete with them because, it's a very big logistical problem sending all these packages all over the place.
Right.
And I said, I'm just going to send logistical cow packages. Because spherical cow packages, because every mathematician has solved this. You just make the packages look like cows. Problem solved.
Okay. Okay, so we're here. So heat sinks. So there's 5 bajillion heat sinks. We've covered other heat sinks, but in particular, let's look for active, and let's look for in stock only because it's just we're going to look for ones that you can get right now. Let's ignore marketplace products, and then you can start looking at actually, ironically, some of the most popular ones are the TO220 because to be honest, it's very hard when you have SMT like CPUs. You can have heat sinks, but TO220s are a very common package that needs heat sinks because they're designed to dissipate a lot of heat through a heat sink, and it's easy to attach one. So let's filter out everything else. So that what we want to do is look for package cooled. So going up to package cooled, there's tons of options here. So let's look for TO220. And so TO220, there's a couple of packages that are similar enough, or they are similarly named, or they can do multiple ones. So we'll just select all of these and apply them. And that gives us, I think, 380 options. So that's kind of nice to see. So a lot of options, and you're probably like, well, how do I know which to get? And the answer is usually you have to do the back calculation of what wattage are you trying to dissipate, and then figure out how much, what is the resistance that you need. And the lower the resistance, the more power dissipation. So some of them actually have a little bit of a cheat sheet here. Like they do give you the degrees C per watt of temperature rise, or the thermal resistance, and you can plug that into a calculator. There's calculators that do that. the wattage is fine. One thing you'll notice is like, okay, this one is 5 watts, for example. If we scroll all the way, it's like, this is pretty chunky power heat sink. So they can get like very, very intense. Let's reshift this because I do like seeing the. Let's see, thermal resistance. Maybe we'll grab this one. Hold on. I have multiple monitors. So power dissipation. So let's put that over here. I don't really care about the package so much. And I don't really care about the series or the tariff status or the type. And they're all going to be active. So let's look at this. So we're looking at price and the power dissipation. So it's the smaller ones, the ones that clip on, that don't bolt on, those are going to be less expensive. As you get to these really big molded ones, like, or extruded ones, they're going to cost more. They're going to cost $2, $3, $4. You can get, something that can handle 20 watts. Like sometimes you'll get chips. Like I've seen audio amplifiers that use or power supplies or motor drivers, and they're like, oh yeah, you can like get like 5 amps, 10 amps through this chip. Okay, sure, but you have to dissipate that heat. You'll want something beefy like this. We can even, I think if we do sort high, low, yeah. These are like massive, massive heat sinks. Like if you think about how big this is, like, it's very chunky. However, I think for something like a TO220, you don't need something that intense. I will say that these little clips, they kind of barely, you have to bolt them on. I find them to be really minimal. They do work if you just need a little bit of heat sinking. But the one that I really think is the bomb, and this one says
Bomb for your bomb.
This one says 4 watts. I don't know, maybe I've never used this, but the one that I really like that I've used and had very good luck with is this one, which is this kind of, it's large, but it clips on and bolts on very easily. And you can see there's like a hole for bolting it on, and it has like a nice dissipation shape. It is a little bit big, but it's also fairly inexpensive, which is why there's so many in stock. So for 30 cents, honestly, I have like 5 of these just like kicking around, and they have a little retainer clip here. You can see, so you can clip it on. You don't have to bolt it. You can clip it on, just see if it's working, and then if you do, you want better, a little bit more heat sinking, you bolt it on. But I like this one. It's Jelly Bean. I've seen it from a couple different manufacturers, but right now, Digi has 25,000 of them in stock from Boyd Laconia. For 30 cents, like this will solve a lot of your heat sinking issues. And then if you really need more wattage, get one of those really big extruded ones, but they're going to be like a couple bucks a piece. So yeah, I've used this in multiple kits, and I really like this part.
All right. That's a great church.
Where in the world is that part I need? The great search with DigiKey.
All right. If things go well, we're going to have a little daily content treat that'll be in a different format in all the different places, in all the places.
Let's go to everyone. Let's do like a quick.
We're going to do an experiment.
We're going to experiment.
Yeah,
We'll see.
So we're digging out things. I have some time capsules.
Time capsule. Does anyone in the chat, there's no prize. Anyone in the chat know what this is?
Yeah, don't say anything.
I'm not saying nothing.
I was tasked to take care of this forever.
You have to take care of this forever. I'm going to give this back to you. But
this
is a blast from the past. All right.
And dug this out of the time tunnel.
Have a great week, everybody. It's good to see y'all later.